welcome Tobias Steinel, your product manager at Instrument Systems. So welcome Tobias, and you will talk about accelerated optical measurement solution with highest accuracy for micro-LED displays and wafers. So Tobias, welcome, and please, the floor is yours.
So let's jump right into it. At Instrument Systems, we have lots of challenges with tech times, but this today, 10 minutes for the talk, that's the most challenging tech time, I guess. So let's jump into it. We talk about fast metrology for displays and micro-LED displays and wafers. And you might know Instrument Systems already. We do a lot of display measurements for years now, and for even longer years, we do LED. And now everything seems to join together with micro-LEDs for displays. The quick agenda, quick introduction to LED, micro-LED testing and metrology. Then some interesting look at the test strategy for micro-LEDs on wafers. And then some examples that we want to show, and also a production tester for micro-LED wafers that we do with our partner Rabitech in Taiwan. And then a little emphasis on metrology in the end. We think that what we call a live calibration is essential for accurate measurement of micro-LEDs due to their specific spectral properties. So here, this is what everybody knows. We can do electroluminescence by contacting micro-LEDs on a wafer. We can contact one or many more, depending on the technology that you're using. Integrating sphere and a spectrometer are the standard devices that we usually sell for this application. But from display, we also know 2D measurements. So you can see we can have a large field of view with many thousands or even millions of LEDs in that field of view using a camera. And also here, a spectrometer is attached for referencing and accurate measurements. And we, of course, can measure electroluminescence if you can contact millions of LEDs, or we can use photoluminescence by pumping light onto the wafer and detect the emission. And that's what we are doing here for right now. 2 examples for photoluminescence. On the left-hand side is our software. So what happens, you take an image that in the largest case that we had so far measures 2 million LEDs at the same time. And then you run some analysis over that. And you will get, for every single emitter, you will get the luminance and color, the dominant wavelength, the emitter size and position. And also, for some reason, I don't have my laser anymore, but never mind. And all of that is traceable back to national standards because we have the spectrometer attached. This gives us the traceability that we need to ensure that we have accurate measurements here. This comes all calibrated out of the box and can be calibrated for more accuracy live on the wafer itself. On the right-hand side, you see a 5-micron micro-LED display in green. You see that we can resolve 5 micrometer LEDs here, and the blue grid shows that each individual LED is detected. So that's just a question of what magnification and what lens you use. Let's get forward. So the test strategy that we're proposing here, in order to be fast and measure many LEDs at the same time, we do photoluminescence on the wafer. Then, of course, there's a gap here in between where we carry LEDs from the wafer onto a display. So we can do testing there too. Some companies do electroluminescence there. Others do this only on the display or also on the wafer. So in any case, we do have the camera and the spectrometer to look at it, be it photoluminescence or electroluminescence on the wafer or display. And the advantage of doing electroluminescence on the display, of course, is that the